The following is an excerpt from the book Experiences of Thought by Anthony Kahn, available now on Amazon.com and Kindle. Who you are and where you come from, blinded by science. This brings us to the final section of this introductory chapter, for we as individuals are model makers, but collectively we function in the same way. Scientists are among the principal teachers of our world, building and refining models, it is hoped, to a professional standard. What is science? It is informed by the scientific method and repeatable experimental outcomes. Hypotheses are conjectured, tested, and adjusted accordingly. But we were already doing that as infants, weren't we? So what? The thing is, scientists have more than just 5 major sensory inputs at their disposal. Over the centuries, and indeed millennia, scientists have invented many ingenious devices that let us see our world in new ways. Some instruments greatly enhance our own senses, but many more tap into data that we cannot access to any extent with our body alone. The other advantage that scientists have up their sleeve is the objectivity of their discipline. A good scientist has their suspicions on how the models should look and behave, and they may be guided by them, but data is king. If the data from your experiment decrees that your model is wrong, then your model is wrong. As individuals, we may let wishful thinking purge the odd data point from our lovingly hewn model of reality, but scientists are not allowed to do this. That is why we have peer-reviewed journals where original research can be disseminated only after scrutiny by competing leading experts in the field. So what is not to like in this arrangement? Well, not a lot really. Science and the scientific method is the gold standard of establishing credibility, and rightly so, for the most part. There are a couple of caveats, though. The first one, as we touched on earlier, is the role of assumptions. The findings of a scientific investigation, when undertaken properly, are robust within the assumptions made. You can rely on that published statistic, assuming X, Y, and Z hold true as stated in the fine print of the methodology. The stuff the media that report the result to the public at large seldom care to read. How many other assumptions could you have made, though? And how would those different assumptions have affected the result? A good study will elucidate on this point, but again, the media will seldom care to read that part. It is fair to say that most of what we take as scientific fact is indeed fact to very high levels of confidence. But there are various branches of the sciences, in particular those referred to as the human sciences, that often must inevitably include a greater degree of subjectivity. And even among the physical sciences, there are those disciplines, quantum physics springs to mind, where there is rigorous and robust experimentation to be sure, but inevitably also a good deal of interpretation. So the generalized reliability and applicability of research output is not quite so ironclad as many, at least among the uninitiated, would realize. That brings us to a second point, research output. This is the currency with which a university's reputation is bought. Publish or perish is indeed the unspoken motto of the employed scientist, assuming he or she wishes to remain so. This culture leads to 2 glaring problems. The first is that quality too often is forced to play second fiddle to quantity. There was a time when the trained scientist had more freedom to lavish attention on their brainchild until it was truly ready to enter the world at large. Now, not so much. If you start to look as though your output is irregular, people will want to know why, but in truth, there are many single works that have taken a lifetime to prepare, that are far more valuable to the world than the sum of the hundreds of mediocre papers dealing with matters of mediocre importance, that are squeezed out of the poor scientist who just needs to have a job. The second problem is politics, for where does it not rear its ugly head? There are yes topics and no topics when it comes to what a university will be happy to grant money for. You won't find them in a written list, but they are there. We are not talking about ethics here either, where unethical research methods are rightly prohibited. Rather, we are talking about topics that are against prevalent wisdom, not lucrative financially, against government agendas, and so on. The problem is that dangerous ideas can be the best ones. The great minds that have shaped the last few centuries of science were largely mavericks, willing to fly in the face of conventional wisdom and question it. Isn't this what a scientist should be? Not a number-crunching drone, but a person with the tools and the courage to ask and attempt to answer the tough questions. Why then do we clip their wings? Dare to propose something a little outlandish, and you will be laughed at. Now, there are many crackpot theorists out there whose theories really don't warrant the light of day, but there are also those whose theories are entirely reasonable. So, what distinguishes a crackpot theory from one that is worthy of consideration? There are a number of things. If a theory attempts to address a weak point in the prevailing model, it must meet a number of criteria. Firstly, it should draw its purpose from the weaknesses in other models that it seeks to address, whilst remaining equally consistent with the evidence. In other words, its very existence should be born out of need, not mere want. In a similar vein, it should also satisfy Occam's razor. That is to say, it should be the simplest foreseeable solution to the problem, and not add unnecessary cogs and gears that are only there to satisfy the theorist's subjective beliefs as opposed to the cold, hard data. This one can be tricky, however, as it is not always easy to differentiate what is objective and what is subjective, given that it once again comes down to assumptions born out of intuitions. Lastly, the theorist's approach should be honest. They must treat the breadth of evidence fairly, as it deserves to be treated, rather than favoring some points and ignoring other points that are inconvenient. If you think about it, whilst there are many theories out there we can instantly put in the crackpot bucket, are there not some beliefs we tend to sneer at, that whilst perhaps unlikely, nevertheless do meet these criteria? Perhaps we should at least give them some thought. Finally, we come to what may be the only true flaw in the scientific method, for those points discussed above tend to be more shortcomings in how science is carried out, as opposed to with science itself. And this flaw is not actually a flaw at all, but rather a limitation. For the cold, hard truth of the matter is that we may be approaching our reality with blinkers on. We have spent these last 2 sections discussing the reality in which we live in terms of a model, and that is quite deliberate. For the model, of course, should not be assumed to be the same thing as the reality it represents. We may refine the model as needs be over aeons of time, to such an extent that every observation is correctly accounted for, and at that point, science will have completed its job. The model will perfectly predict everything that our physical world can throw at us. But does that mean that the model is now the same thing as reality? Well, actually, no, it doesn't, for we cannot know that. It just means that it is the perfect tool for understanding anything our reality can possibly throw at us. But isn't this just splitting hairs? The problem is that in the philosophical sense, already we can see a problem, for right there we are met with something that science cannot possibly answer. For if we concern ourselves purely with measurements, we are locked into the assumption that the physical universe, as we experience it in our daily lives, is the entirety of reality. But again, science could say nothing concrete with regards to the question of a realm of experience that lies beyond that which we perceive as physical. There may not be any such realm, but then again, there may. Sure, anything might exist, but why introduce an extra cog into the model when it's not needed? Well, that's just the thing. There's good reason to believe that it may indeed be needed to give us a complete understanding of the reality we find ourselves inhabiting. There can be no denying that science is the rightful king in the domain of understanding the physical universe. But what is the physical universe? What indeed is physical? Perhaps in the end, science must take its place as a vassal king to the more widely encompassing breadth of philosophy. If you love wisdom, then you must be a philosopher. This completes Chapter 1. The story continues in Chapter 2 with that old-time religion.